Today we're going to complete Student Handout 4, Simplifying Expressions with Properties. Much of which you are familiar with. We'll go through the definition and example. And the first property is the associative property of addition, which means when adding terms, the grouping will not impact the solution. Which basically means if I have 3 add-ins, notice the order is the same. If I group my first 2 add-ins or group my second 2 add-ins, the sum will be the same. Order's not going to matter. On the associative property, when multiplying terms, the grouping will not impact the solution. So basically, the associative holds true for addition and multiplication. Again, if I have 3 factors, keeping them in the same order, but changing their grouping, the associative property proves these 2 expressions would be equal. The commutative property of addition is when you're adding terms, the order in which they are added can change. If I have A plus B, but change the order, the associative property of addition proves they are equal. The commutative property of addition. The commutative, changing order, stays equal. So our commutative property of multiplication basically states the same thing. So we basically say that multiplication and addition are commutative, meaning if I multiply A times B or B times A, I have not changed the product. I'm going to get the same answer. So we 4 things, but really just 2. The associative property works for addition and multiplication, and so does the commutative property, addition and multiplication. We'll abbreviate these using acronyms such as associative property of addition, we'll say associative property of multiplication. This one we think of as associative property, I did it again, commutative property of addition and commutative property of multiplication. And that's how we abbreviate that. The last property is our distributive property, which we have used a lot in student handout 1 through 3. And the distributive, expanding an expression through distributing, makes sense. Basically claims that this multiplication problem, and it's a multiplication problem because order of operations would say add first, multiply last, is equal to this addition problem. And this becomes an addition problem because the order of operations would say multiply first, add last. So multiplication, factor, factor, addition. The next chart is basically reviewing our combining like terms, and we simplify expressions by adding and subtracting our like terms. So the combining is the adding and the subtracting. An example, not the example, but an example for that could be 6y plus 7 minus 3. 3 terms, 2 like terms, and I can use my commutative property of addition Notice that negative term. To change the order, then I can use my distributive property. Let's go ahead and add that acronym. Then I can use my distributive property, which means I'm going to factor out that common factor, and I'm going to sum the coefficients, which basically we're stating here, we have the addition is equal to the multiplication right here. The addition is equal to the multiplication. And then we just simplify. That's going to give me 6y plus 7. And so that would be an example. And I ran into the next box. So the equivalent expression terminology basically says that two phrases that are equal but written differently. Obviously they don't have to be equivalent, but they could look different but actually equate to the same. So the example that we use mostly for this is our multiplication, addition, equivalency of that distributive property. For example, we're claiming that, and hang on, pausing a moment, my pencil broke. Okay, so we have two expressions that are equal but written differently is often shown with that understanding that the multiplication of a factor and an expression as a factor is equal to this addition problem by using that commutative property. So we're basically understanding that what we call that is equivalent expressions. Now, what we're going to do next is work through some problems that we already know how to work, but we're going to make sure that we're justifying that. Notice that they put the word given here. We're not going to, hang on. Let's mark this out. We're not going to mark the appropriate letter from the box above. We're going to use the acronyms. Let's look back and I'll show you what I'm talking about because I left one off. So if I use the associative property, which in this case we're not going to, mostly what we're using is the commutative of addition and the distributive. Then I'm not going to mark the letter. I'm going to mark the acronym. And so we would begin with the distributive property. By multiplying each addend by not just 3 but negative 3. So we know that that negative 3 is going to give the opposite of each term inside. So currently we're just going to simplify, and that's going to give me a 12x negative, negative 9, positive 5. And so what we did was simplify. We could add that as our step. But you won't spell that right. There we go. Now the next step would be to move our terms using the commutative property of addition. Moving our terms so that I can sum my like terms. Now because I'm showing all steps, I'm running out of room. And our next step then, which I'll just simply add right below it, is that distributive property again. Because that's where I'm going to factor out the common factor of x, which is in this case when we're simplifying, it's always the variable. Even if there's another factor they have in common, which 12 and 5 don't, but. And now I'm going to simplify because that will give me a negative 7x. I'm also going to simplify at this point that double sign, add a negative, subtract a positive, and we are done. Now, what I'm going to show you in the next example is how we can eliminate one of these steps. First, I'm looking at my problem. I see 3 terms in parentheses, positive, positive, negative, plus a factor of 2, and then an expression that's used as a factor, x minus 6. So, first step, always perform all possible operations. What's possible at this point is the distributive property. Carrying down and eliminating the parentheses, because that first set of parentheses is doing nothing at this point. Now, I'm going to eliminate this step here. You can write it, but it's not necessary. Because I can think 2 times x is 2 times x. And 2 times negative 6. 2 times negative 6, negative 12. Next, we are going to use the commutative property because I like to see my terms in order that you're adding them, left to right, making sure you have all your like terms so that you can sum left to right. And now we're ready to use that distributive property. I can add these two right now at this point, which would give me a negative 16. And so my justification would be distributive property here, simplified here. And then we just have one step to finish, which would be to add, carry down the positive 6y, eliminate the double sign with a negative 16. So to justify that, we call that simplify. 3 terms, 2 positive, 1 negative, no like terms. That's how you know you're done. Flip it. Almost finished. By substituting a value for each variable, you can check that the expressions are equivalent. So they want me to simplify, then justify. So I'm going to do 2 things. Simplify, then justify with mathematical properties and phrases. Prove you are correct by evaluating the expression when x equals 2 and y equals 1. So step 1, we're going to simplify first, which, look at that negative. Remember, distributing with that negative is going to create the opposite of each term inside. So we have a positive 3x becomes a negative 3x. Positive 2 becomes a negative 2. And because this is a plus sign, then I can also eliminate these parentheses at this time. 4x, 2x, negative 10. Or if you want, you can go ahead and make that a plus a negative 10. But what we did use is our distributive property. Our next step is then to change the order of the terms so that you can combine your like terms. That's your commutative property of addition. To combine your like terms that contain a common factor as a variable, we use the distributive property. Carry down the 2y. I can go ahead and add these. Distributive property, simplify. When I add negative 3 and positive 4, I'm going to get 1. Eliminating the double sign, I could say I'm finished, but there's one thing that I have that I don't need. And that would be the understood one in front of my variable. So I'm going to eliminate that. And your final answer would be x plus 2y minus 12. And what we're going to do, and you're going to have to write small so we can squeeze it in, is we're going to substitute each expression, then simplify. Well, first we'll substitute x for 2, y for 1, and then we'll simplify. And prove they are equal. Make sure you didn't make a mistake. So we'll start with our negative on the outside of the parentheses, very important. Those parentheses are very important. Writing pretty small. What we're trying to do currently is show that, well, we'll put them right now, just to make our original problem look the same. So we're basically claiming that this expression, which contains 1, 2, 3, 4, 5 terms, is equal to this expression, which only contains 3 terms. So to prove that, we'll substitute. We'll do the left first. Line 2, every x, substitute for a 2. Every y, substitute for a 1. And now you're just calculating, following the order of operations. So the first thing we're going to have to do is work inside our parentheses, which that gives me 6 plus 2 will give me 8. And then we have 4 times 2, which is 8. And 2 times 1 minus 10, and or we could say plus a negative 10. Either way. Most important, this is the opposite of 8, which is negative 8. And 10 plus a negative 10 is 0. So I'm getting final answer, original expression, negative 8. What we want to do is substitute our simplified expression also with the same variables. That's the only way it's going to work. And calculate. 2 plus 2 minus 12 or plus a negative 12. Either way, it checks, and they are the same. We will have more practice with this type of proof in other stations. What I want you to do now is take a moment, you and your group. I want you to work through all 5 of these problems, and you may use this space below if you need extra room, and you probably will. You're also welcome to get a sheet of loose leaf if you prefer to work them on the loose leaf. We have 5 problems. Pause the video and begin. At this time, you need to check each answer. Make sure you pause the video. Give each one of you time to check.